All right, Algebra 1, we're going to get started with our lecture. It is on sections 2.1 through 2.5, which covers negative numbers, adding, subtracting, multiplying, and dividing. So I'm hoping this isn't moving too quickly because I'm hoping this is a review. However, if you're struggling with negative numbers still, definitely ask me for extra help. Here we go. So section 2.1, Introduction to Negative Numbers. So here's a number line, and I think you've probably been seeing a number line, at least with positive numbers, since you were quite a bit younger. Each point on the line represents a number, or the bigger the number, the farther it is to the right. Numbers to the left of 0 are called negative numbers. The minus sign is used to represent a negative number. All numbers that have a place on the number line are called real numbers. This includes decimals and fractions, both positive and negative. It includes decimals that repeat or decimals that go on forever. All right, so let's look at a couple of examples if we were to do some adding using our number line. So 2 plus 3 equals 5. So we start at the number 2, and then we're going to move 3 spaces to the right. 1, 2, 3. That's 3 spaces to the right, and we get 5. So that's how you use a number line to add. Which I don't think you need to do, but hopefully it will help you understand negative numbers and why we add and subtract them the way we do. So if we start on 4 and we have to add 3, or add negative 3, then we're going to go 3 spaces to the left. So when we added positive 3, we went 3 spaces to the right. And when we add negative 3, we're going to go 3 spaces to the left. 1, 2, 3. So 4 plus a negative 3 is 1. Okay, we'll do 2 more examples. We'll start at negative 1, and then we're supposed to do negative 1 plus negative 3. So we'll go 3 spaces to the left. 1, 2, 3. We get negative 4. Okay. Pause the video and make sure you can do this last example, negative 2 plus 7. Did you pause? All right, great. Maybe you already know this. We'll start with negative 2 and add 7 and go to the right. 1, 2, 3, 4, 5, 6, 7. So when we added 7 to negative 2, we got 5. Okay, adding signed numbers. So we need to do our basic math without a number line. Many of you might already be able to do this. We have 2 vocabulary terms for this lesson in section 2. The first is that 2 numbers are additive inverses or opposites of each other if their sum equals 0. 2 and negative 2 are additive inverses or opposites because 2 plus negative 2 equals 0. Another thing Forrester talks about in the book in this section is absolute value. And I maybe could have skipped it here, but I'm sure he's going to bring it back up in later sections. And so I figure we'll introduce it now and then we'll go back to it in a lot more depth later. So the absolute value of a number is written with vertical lines. Often the vertical lines are kind of extended so that the number doesn't look like a 1, or so that the lines don't look like a 1. So there'd be these 2 vertical lines and then a number in between them. Or we can get fancier things in between there too. Let's just start with a number. So the absolute value of a number, written like that, is its distance from the origin, or 0, on the number line. So our basic example is, because 5 and -5 are both 5 spaces from the origin, the absolute value of -5 is 5, and the absolute value of 5 is 5. So I'll show you what I mean. So here's -5. The absolute value is going to be the distance from the origin. So 1, 2, 3. I already messed it up. Sorry. 1, 2, 3, 4, 5. That's 5 spaces. And it will be the same if we go from +5. 1, 5. And so we call this like a distance. Think about if you're going to Target and it's 5 miles away, you're not going to say, oh, it's -5 miles from my house. So we're talking an absolute value, and that means you're going to be working with positive numbers. So let's try examples. The author gives an explanation of how absolute value can help us with adding signed numbers. However, I found that more confusing than helpful. So we talked about absolute value. There will be a couple of basic absolute value problems in your classwork, but I'm not going to go through his whole explanation. But you can feel free to read that in the book if it would help you understand how to add signed numbers. So our first case is if we're going to add a positive number to a negative number, and the negative number is the smaller number. So basically, all we need to do is take 7 minus 4 and get 3. And we get a positive answer because the bigger number is positive. The second case is if we add a positive number and a negative number, where the negative number is larger. So we're still going to be doing subtraction, 7 minus 9. But the way we calculate this is by taking 9 minus 7, which is 2, and then tacking on a negative to get -2. And that's because the larger number is negative, so the sign comes from the larger number when you're adding signed numbers that are opposite, one being positive and one being negative. Our third case is if we have 2 negative numbers. If you have 2 negative numbers, then you simply add them like you would add positive numbers. 3 plus 4 is 7, and you tack on a negative in front. -3 plus -4 is -7. The last case, what if our negative number is first, -3 plus 4? Our larger number is still positive, is the positive number. So we take 4 minus 3 is 1, and that's going to be a positive 1 because our larger value is positive. Okay, we're moving on. So there are some definitions that the author gives in the book that are important, and you will have problems in your classwork that involve these. Hopefully most of them you already know. So the first one is that positive numbers are greater than 0. Negative numbers are less than 0. Integers may or may not be a new term. Integers are the numbers that are negative, positive, and 0, but no fractions and no decimals. Real numbers, I think I mentioned this in the last section, but I'll go through it again, that real numbers are all the numbers on the number line, including fractions, decimals, and negative numbers. So maybe you're super curious and you're a curious George, and you're thinking, if there are real numbers, are there imaginary numbers? Yes, there are. I don't know that we'll get to any imaginary numbers this year, but you would definitely see them in Algebra 2. So we're going to move on to section 2-3, which is subtracting signed numbers. So subtracting a number is the same thing as adding its opposite. For example, 7 minus 3 is equal to 7 plus negative 3. What if we're doing 9 minus a negative 5? So that's the same as doing 9 plus the opposite of negative 5. What is the opposite of negative 5? Can you pause and figure it out? The opposite of negative 5 is positive 5. So 9 plus the opposite of negative 5 is just 9 plus 5. So if you have minus a negative, you can change it to plus a positive and just do 9 plus 5 is 14. 2 examples would be a good idea to pause and try to work them first before you watch me work them. So go ahead and try to get these 2 examples done. Did you do it? Okay, let's see if you did them right. So 13 minus 29 is the same as 13 plus a negative 29. So now this problem is like the problems we were doing in the last section. We want to actually subtract the numbers. They have opposite signs, so we subtract them. 29 minus 13 is 16. But the answer is not positive because the number with the larger value has a minus sign on the front. So we get a negative 16. Okay, example 2, negative 4 minus 3. So again, I'm going to change this minus to plus a negative 3. So negative 4 plus negative 3. These numbers have the same sign, so we add them and we keep the sign. Okay, now those sections were the hard sections. I'm checking my time really quickly. But I can't see it easily. I don't know why. Okay, well, I'm just going to keep going and hoping that's not too long. So section 2-4 is multiplying signed numbers, and this is our easy part. If you multiply 2 numbers with the opposite side, the answer is negative. Example, negative 2 times 3. 2 times 3 is 6. The signs are opposite, so it's a negative 6. If you multiply 2 numbers with the same sign, both positive or both negative, the answer is positive. So negative 2 times negative 5 is positive 10. What if there are more than 2 numbers? You can just go step by step. So you could do negative 3 times negative 8 in this example is positive 24. Negative 2 times negative 1 is positive 2. 24 times positive 2 is 48. And then these 2 things are pretty important because they're hard to remember. If you take a negative number and you raise it to an even exponent, you're going to get a positive result. If you take a negative number to an odd exponent, you're going to get a negative result. So in example 1, negative 2 in parentheses raised to the 5th power. That would be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. See how there are an odd number of negative signs, 1, 2, 3, 4, 5, which means the answer is going to come out to be negative. 2 times 2 is 4. 2 times 2 is 4. And then we have a negative 2 left over. 4 times 4 is 16. And 16 times negative 2 is negative 32. This example is interesting because there are no parentheses around the negative 3. So in fact, this does not always equal, or not necessarily equal, when you add the parentheses. So this is actually asking us to do the opposite of 3 to the 4th. So that means the answer is going to be negative. And 3 to the 4th, you can work out on your own, comes out to 81. So we get negative 81. But negative 3 in parentheses raised to the 4th power is going to be positive 81 because this is an even exponent. So all the negatives will get paired up with a buddy and turn into positives. Section 2.5 is on the division of signed numbers. And basically it works exactly like the multiplication of signed numbers, because if they're both positive, the answer comes out both positive or both negative, the answer comes out positive. And if they're opposite signs, the answer comes out negative. But the author does talk about another vocabulary term. Two non-zero numbers are multiplicative inverses or reciprocals of each other if their product equals 1. And then there's a note that 0 does not have a reciprocal. An example of reciprocals that we call them multiplicative inverses would be 2 and 1/2. If you take 2 times 1/2, you will get 1. If you have a fraction, it's even easier to find the reciprocal. The reciprocal of 2/3 is 3/2. And if you multiply these two numbers, you would get 6 divided by 6, which is 1. So 2/3 and 3/2 are multiplicative inverses. Dividing a number means multiplying by its reciprocal. So an example is usually with fractions. So say you want to take 2/3 and you want to divide it by 4. What you're going to do is you're going to copy the numerator, change it to multiplication, and flip the denominator, meaning you take the reciprocal of the denominator, which would be 1/4. So this would give us 2/12 or 1/6. And I got that by multiplying the numerators and multiplying the denominators. Because 0 has no reciprocal, division by 0 is undefined. So 3 divided by 0 is what we call undefined. So if you're asked to find what is 3 divided by 0, the correct answer is undefined. However, if you take 0 divided by a number, when 0 is on the numerator, it will come out to 0. Okay, so I kind of already said this, but when we're doing division with signed numbers, negative divided by a negative is positive. Positive divided by a negative is negative. Negative divided by a positive is negative. Okay, So negative 54 divided by 9. Go ahead and pause the video. Make sure you can get all three of these right. Pause. Okay, good job. Negative 54 divided by 9 is negative 6. Negative 3 divided by negative 2, that comes out to an improper fraction, but to write it simplified, we want it to be positive. So I would write that as positive 3/2. 55 divided by negative 11 would be negative 5. The end. Good job. Well, hold on, just a minute.